I'm John. I'm a senior DevSecOps from Topan. So I'm the one you usually will call during issues like network outage or if you have problems with your cloud loss. Okay. So my topic is empowering operational excellence. So we have seen now that we've designed applications, we now built the application. Now, once you have your application there, you need to make sure it operates well. Okay? So how do we empower operational excellence? Before we start, when you think of operations, what kinds of words do you think? What kinds of topics do you realize when you say operations? So here are actually some words that I thought of during the time when I was thinking of how to handle operations. So it makes me think about things like security, like management. It makes me think about how the network will deal with traffic, how I can monitor what's coming in. Uh, so I'm also thinking about virtualization, like we put this on a container, like what happened during the design. But there's one word actually that's not here that I want to highlight. That word is support. So when you're doing operations already, one important thing we have to consider is the support. So support will be your lifeline during the operations phase, wherein without support, your application sure will keep running. But if you encounter an error, problem, an issue, they will be the ones who first investigate for you. Okay? For us, uh, you usually have your traditional FM for this, right? But I also want to highlight that there's something beyond the traditional FM. Right? We call those things cloud ops. So before I discuss what cloud ops could be or would be, I want to highlight traditional FM first. So when you think about traditional FM, you'll see if you think about dashboards, think about monitoring. Maybe you'll think about how we are able to see your CPU usage, your memory, your disk usage, your network traffic, all those things, right? That's what a traditional FM would look like. But when I talk about cloud ops, I don't want to think of all of that. So, no, we shouldn't think of all of those things. We shouldn't think of it as a traditional thing. Okay? So when I say no, I don't want to think of monitoring and such. Then what if there's a problem, right? If I don't do monitoring, if I don't do those stuff, how will how will I be able to operate in excellence? So before I continue, who here rode a car today going here to the maybe took the public transport or maybe have taken Grab before going to some place, right? So let me give you an analogy first. So let's say you were riding a car, you had a problem, you were with your friends, or uh, you encountered an issue, you had to stop by the side of the road. You can't solve the problem on your own. So what do? You call your support. Right? Your support will bring you to your mechanic. Your mechanic will start looking at your car. You tell your mechanic, oh, my engine doesn't want to run, my engine doesn't start. So he starts looking at your dashboard and sees the sign for the dead battery. So your mechanic will tell you, okay, you have a battery problem, let's replace your battery. And once he does replace your battery, your car starts, you're good to go, right? That's what your mechanic does. But if you're brought to your service center, your actual car service center, they will look at your dashboard, see the battery indicator, think the same thing as well. You have a dead battery. But they have other tools. They have access to your history, your car history. They also have access to your car logs. So they look deeper, they see, oh, your battery is dead because your car cannot provide enough electricity when it's running. So it's slowly degraded over time. So now you know that you need to replace other parts, not just the core battery, right? So in this, I'll bring you the traditional FM, which will take a look at your dashboard, take a look at whatever monitoring, whatever alerts you set up. But for cloud ops, we dig deeper. We are not satisfied with just saying, oh, there's a CPU alert, maybe high usage. There's a high network traffic coming in. We need to increase bandwidth or something, right? We're not satisfied with just that. We need to look deeper what's causing this. Okay? So there's two terms that have been thrown out back and forth earlier. The first term is monitoring. So just I think a lot of us knows what monitoring is. Basically, it's whatever pre-configured telemetry we have, just to understand what the current status of our application is, right? But we've been thrown around this term, observability. So observability is our ability to understand actually the inner state, right? So that means we're not just looking at monitors, the metrics that we have. We're not just looking at the CPU, the memory. We're not looking at those things only, but we're looking deeper. We want to know what's important to us. Is CPU important to you? Yes, but there's something more important in the business aspect as well of your application. Okay? So a little bit more. So if you think about monitoring, like earlier, you usually ask what happened. If there's an issue, is this a recurring thing? And your traditional FM will usually ask, is this fixed noted down in your documents? That's why we give them operation manuals, right? But if you take a look at observability, we go further, we go deeper, the rest of the iceberg. We try to ask, why did it happen in the first place? So we also ask, even if our resources are high, our usage is high, is the system still performing well? Or how can we improve the resilience? Right? So this is the difference between just looking at the surface and trying to dig deeper into your application, into the status of your system. Okay? So think about it. If you have issues, if you have problems, what would happen? In the traditional sense, you'll encounter slowness, right? Or even possible downtime. So you'll be screaming out of your head, shit. Okay? Things are happening, things are ongoing, and how do we solve it? So I'm here to provide you a sense of what we did for us. Okay? So one thing that we try to avoid, of course, even all of you for sure, is having your user call you, message you, oh, we have a problem. Our system is slow. This is something that we want to avoid, right? So with the traditional FM, this is usually how it goes. Your users or the people using your system will be the ones who are telling you there's a problem. So this is not the thing that we want. Okay? So here's things that happened to us. So at one time we receive an alert. Our database CPU is extremely high. This is the traditional metrics, right? The database CPU. Okay. So of course, traditionally you check also the memory and CPU usage of your application. But this time around, when we check, there's no usage to any of our applications. So it's quite baffling why our CPU usage is high, right? So instead of trying to figure out from our traditional metrics, we employ the use of our EMS, the one that's being talked about earlier. So with EMS, we're actually able to see. Before the EMS, if we go about it traditionally, you'll see your traditional FM will call you. Your application team will ask for the logs. Your FM will give you the logs, and this will go back and forth until the solution is achieved. Right? That's how usually it happens. How it happens. So instead of doing that, we employ EMS. So using EMS, we're able to see the transactions that are currently happening. Since it's a database issue, we're seeing there's no usage in our application, no usage in our web tier. We go to our database information, we see there is a spike in the latency of our transactions. We go through the slow points of our transactions and pick maybe one or two, go deeper, right? So going deeper into one or two of the transactions, we see all of these details. So there's a lot of details, right? This is usually what you want to see when you're given the idea of observability, right? Because monitoring of CPU and memory stuff, you want to see your actual transaction going through your system. What's taking so long? So from here, actually, we're able to identify a few things. So one thing we can identify here is that there's a commit transaction that's taking a lot of time for our system. So and this commit transaction is of course an update. So updates for people who know database here, updates cost a lot of CPU headroom for databases, especially if your tables are indexed in such a way that too many calculations have to be made, right? So, okay, fine. This confirms that the reason why CPU why the database CPU is getting hit so hard. Right? So, but it still didn't tell us what's the reason behind it. So we go into our logging. So talked about earlier, microservices logs microservices have their own logs. So the main problem with their own logs is that you need to centralize these logs. Right? So using another part of our EMS, we centralized already the logs here, and we took into account the time of the event. The time of the event is 8:30 a.m. Then we check. It's a batch job actually that's running. So it's right on the dot, 8:30. So this shows us that the reason behind the database is another update statement. So this batch job actually does so many updates, so many records. It goes through so many tables that it causes the high CPU usage. So for us, what does this mean? Since we're cloud ops, we were able to find out things even before you have to go through all the other things. Thanks to our EMS. So with this, we informed the application team, why is there a batch running in this at this time? Is this expected? So our application team now tells us, oh, a deployment occurred the day before, and the batch job was configured incorrectly. It was configured at 8:30 a.m., wherein in fact it should be configured at 8:30. Okay? So that's one way it helped us having better observability in our application. Okay? So that's my first case. So just from this one case, I'm seeing that if I'm able to see deeper into my application, it can immediately tell me, or it can help me identify problems right. So it took me another case study, showed me another thing, slowness again, sure. But this time it involved both the web page and the application. So you see here, yeah, there's spikes. It's not very high spikes that would warrant usually alerts, but thanks to employing some machine learning, we're able to identify spiking here. So we check the web page latency API that is going up. But when we check the CPU usage of memory, it's still quite low. So another mystery in this case, right? Usually your latency will go high as your application is processing more things. You'll tell me, oh, it might be the database again. Okay, this time it's not the database. Okay. So we go through just the app web. We try to figure out where the latency is coming from. So going through the slowness points again, we identify that at this specific time, there's a problem that's occurring. So you see that there's just a few specific lines wherein the response time was quite slow. So we see what this portion of our application is. We see that there's a client request. That means if there's a request going out of our system to another system that's causing the problem. So we dig deeper, we don't know what this is. So we don't. When we check the traces for this, since we have all the loggings, it's compiling, we're consolidating all the logs, all the traces. We're able to see that there's an API call being entered. There's an API call that's causing the slowness. So digging deeper, this API call causes 34 seconds of our application to go back just like that. So it's a big thing, especially when we see the requirements from other applications where the response should be 3 or 4 seconds, right? So it's a very big thing. So we drill down deeper. Since we have all the traces, we have all the logs, we're able to drill down that through the application's requests. We find actually that there's an API service to an external API that's going down. Of course, our system, for sure, any system that's calling other microservices should have a retry in calling this API service. So we do have in this application, but after retrying so many times, it was only able to reach the API on the fourth try. So what does this tell us? This API is an external API. This is not internal. So one thing, if we're the support, we can immediately say that this is not our application problem. That saves you a lot of headache. Second thing is that it shows us which API is being called that has a problem, right? Without this information, we cannot determine. We are not able to find out what was wrong. People may say that our application is down because of this, but thanks to this, we're able to inform the other system. We're able to inform their team. We need more resiliency during this time because we have transactions going on. So for this one, it was because they have an unplanned maintenance. Like what happened earlier, what was explained, there was a rollover happening. So there was a few seconds of downtime for them. But luckily we were able to recover because of the retry. But without the news, we wouldn't be able to tell the client about this. So thanks to those two things, we never got a call from our users. We never got the dreaded PM, our system is slow, or our system is down, please check. Then suddenly you are being sent an email, oh, there's a critical severity 1 issue ongoing. So what does this mean for us? So since I've been talking about traditional FM since earlier, you know your traditional FM will monitor your application through your infrastructure. You know your traditional FM will raise the problem if they cannot find the actual solution in the operations manual that you gave them. And we know that they might not have the required tools or experience in actually handling the issue. But for us, since we have the measures in place, we try to improve the observability of your application. We now have deeper tracing and troubleshooting. So we have also, since we have all this information, we can understand your application more. And since we have the experience, we can coordinate with the cloud provider to provide you with better solutions. Not just restarting your application, not just following what was in the operations manual. Okay? So how do we achieve this overall? So we achieve this through 3 things: metrics, logging, and tracing. For metrics, it's the same. Sure, we have metrics like CPU, memory, network, but we also, since we have all the information of your application, all those information that you give, we also want to highlight meaningful metrics. Those metrics that are important to your business. So that's why you need to learn your application once it's useful. Then for logging, like earlier, microservices tend to have distributed logs. So we will try to centralize the logging, timestamp it properly, so that we are able to do effective tracing through your application. So with all of this, from the start earlier, by CK, there's now design, then we built with Darren, and now with me, we're now operating. So we're operating with excellence through this by improving your observability of your application. So with all of this, actually, we are now thinking, oh, so we have everything in place, right? We can now go on vacation. So yeah, I actually agree with that. If we have everything in place, yeah, we deserve application after all the effort we put into our systems. Okay. So bottom line is, our traditional FM may not be the thing that we need now, since we're moving to cloud-native blocks. We can't be satisfied with just doing monitoring on a surface level on the CPU, the RAM. It's not enough anymore. We need to improve our applications observability, and we need to move from traditional to something like our cloud-based. So then, thank you, everyone. So I have a question here. Does Topan provide DevSecOps even if the system is not deployed by us? We do provide DevSecOps even if the system is not deployed by us. So if you do want to commission us for your support, great.
So I'm back up here because I sorry for missing out a few questions earlier because I thought I want to hand over to the next speaker. Yeah, so I will cover this question now. So first one is more on stream processing part. As mentioned earlier, no database was used in the main request. If the user scans the QR code to register multiple times, do they see OK every time? The answer is no. Only the first request will go through, because when you use an event streaming platform, even though things are on the fly, but it's still done in a very orderly manner. So when your first message goes in to the event stream, and the second one comes in subsequently after that, it gets queued behind the stream. So it's only when the first message actually gets processed, and the second message then goes in, and by the time the second message gets processed, it's actually already registered. So it will not be we actually tested that in the setup, and that is really how it works. So it's, even though it's streaming, doesn't mean it's chaotic. Things are still in a very orderly manner, and there's a guaranteed and delivery in the platform. So you can think of it as it's not going to be so-called creating a loophole for itself. So the next one is actually a very quick question. So was the project hosted in AWS? Understand in Singapore there's only 2 AZ. The fact is that all the 3 CSP in Singapore that under GCC, they all have 3 AZ. And as I mentioned before, there's 3. The number is 3 for a reason. It's not by chance, or it's not a random number that was given by the CSP. In fact, you go to AWS across globally, they are all 3 AZ there. So for those that has less AZ, we will gradually build up to 3 AZ. Because 3 is the number to achieve to do your so-called modern way of clustering using this consensus approach, forum approach. So that is going to be the way forward. Any cloud provider without 3 AZ is not going to survive it. That's what I can say. Because that is how modern software actually works. Yeah. So I think I'm done with my question.
Thank you very much, Darren. Thank you, John. Thank you, CK. I'm glad I was one up here answering some of the questions. It will be quite challenging. Yeah. So we have now come to the end of the seminar. So we're moving on to the next segment, which is the lunch. The tables are all set up behind. We already don't know. We have also assigned the table to each one of you already. If you don't know which table to sit, I think my colleague Gerald, we can put him or Kopiong behind. Just raise your hand. Okay, can direct you to the table. So your names, the name tag also put on the table so you can identify which table is yours. Okay, so once again, thank you very much for being here. So I would like to invite you for lunch. Thank you very much. Oh yeah. Okay, one more thing. Yes. We appreciate the feedback. And you can just scan this QR code. Give us your feedback on this seminar. We will really greatly appreciate that.